In this video, we will find a vector which is normal or orthogonal to a given plane. So the problem here says we have a plane and it contains 3 points. We'll call them P, Q, and R. Then we need to find the normal vector to this plane. So a vector which is perpendicular to this plane. Now the idea is to use the cross product. We know that the cross product of two vectors is orthogonal to both of those vectors. So to find a vector orthogonal to the plane, it will be enough to find two vectors in the plane, and then we can just take their cross product. But since we have 3 points, it's really easy to find two vectors which are in the plane. Just take any two vectors which point from one of these vertices to the other. So for example, we could take P to Q and P to R to be our two vectors. So let's do that. Let's call the first one V, which will be in the picture the vector from P to Q. So in components that will be 3, 4, 6. And then let's call the second one W. So in the picture, that's the vector that points from P to R. And in components, that will be -4, 0, 5. So, as I said before, we now want a vector which is orthogonal to the whole plane. We can find it by finding a vector which is orthogonal to V and W, which we can just take to be the cross product. So our final answer, our non-zero vector which will be orthogonal to the plane, will be the cross product of these vectors V and W. So remember how we compute the cross product. We can think of it as a 3x3 determinant. In the top row we put these standard basis vectors I, J, K. The second row we put the components of V. In the third row we put the components of W. And then just expand this determinant. So let's see, the I position will be 20, the J position will be -39, and the K position will be 16. And so there we have it. This is a non-zero vector, and it is orthogonal to the plane that we were given at the beginning.